Hey everybody, Mr. Stewart back for a fourth time in our series on creating and connecting representations for linear relations. Whew, say that 10 times fast. Now I understand this is not a math antics video. That's a lot of, high production and a lot of time put into it. So I'm hoping that you're getting some valuable takeaways from this. So last time that we were focusing on our video, was we had created a table of values on the left here from the graph that you see on the right. So our goal this time is to focus on how would we take the equation. If that's all we had, and we had to produce the table of values, what would we do? Okay, so, well, let's give it some thought. So let's assume that, this work here, doesn't exist. We've done nothing here with this table. So let's get rid of that, okay? And before we do walk away from that, I just want to let you know what you can see here is that the graph, the y-intercept is at 0, 3, okay? That 3 is the initial value, the very same initial value we have in our equation. Okay, so in a tiling pattern, if you want to refer to that in a tiling pattern, that would be the 0th term. So if you look at your term number or position number, that's term 0. Okay, if you want term 1, then what you would have to do would be to put x equals 1 into your equation. Follow BEDMAS in order to solve for how many tiles are in your tiling pattern. Okay, so just hang on to that information for now. Okay. Just going to get rid of that. Also, before we talk about the table and the equation, what I want to let you know, and you may very well already know this, is the following. So this information here, right, in the rate triangle, that rate is what allows us to move from one diagram in a tiling pattern to the next one. Okay, it's the rate of change. And in this case, it's a negative rate of change because the line, as you read the graph from left to right, is falling to the right. So our rate of change is for every increase of 2 units in x, there's a drop, right? A decrease of 5 units vertically, okay? So you can see that rate of change is right here, okay, in our equation. So that's a connection between the equation and the graph. That's how you can write the equation from the graph, okay? So good information to know. But our job, our task is to take this equation and it's to produce a table of values. So how do we do that? Well, there's a couple of ways that you can do that. One is very efficient. Both are effective, but one is definitely better than the other. Okay? So here's my suggestion to you. So for the 0th term, that's your initial value or your y-intercept. I would always start by putting that into my table of values. So it is the 0th term, which means that's what x equals. And when x equals 0, in this case, y is positive 3, because that is the y-intercept. Now what we can do from there is we can look to our equation and we can use the rate of change, which is negative 5 over 2. So again, visually, that means this here, okay? Drop 5 units for every 2 units as we increase x. So why don't we take this increase in x, okay, let's take this here. So let's take the 2 and let's reflect that in our table of values. So that would be this. Much like the movement horizontally on our graph. So if we do that and add 2 each time, right, we'd end up with that. Now on the other side, okay, so what we're looking at, really these are your first differences. I may have mentioned that before. So first differences in x and first differences in y. Okay. And of course it's linear because there's a constant increase in both y and x. So if you look at the difference here, again, focus on the rate of change. And this time we're going to be using the -5. So we're going to be dropping 5 units. So we'll just subtract 5 repeatedly. And from that, well, we'll have our answer. So 3 minus 5 is -2. And then -2 minus 5 is -7. And -7 minus 5 is -12. Now, in order to check that, we could go back and we could check the graph. That would be helpful to see those values are on there. And many of them, as you can see, they're already there. Okay. Now, another way to check too, and it's another way to build your table. So what I'm going to do is I'm going to take, or at least make some space here. I'm just going to remove this information. We'll keep all that other stuff down there. And I'm just looking to create a space where I can kind of work. So maybe I can even move that graph out of the way. Yeah, I can. Let's do that. Let's move that out of the way. So what we'll do is this. Why don't we, check some of these values? So I'm going to write the equation out up here. So negative rate of change times the position number in a tiling pattern plus how many tiles are in the very first or the 0th position. So for term 0. So what we'll do is, well, let's test it. Okay. Let's take this one, for instance. Let's focus on this. So why don't we take x as 0? Okay, so what we're going to do is we'll take 0. Can't see, oh, there's 0. Okay, we'll take 0 and we'll substitute it in for x. So let's do that. Okay, so -5/2 multiplied by 0 plus 3. Well, anything multiplied by 0 is 0. So therefore, y must be equal to 3. So that means that 0, 3 actually is a point on the graph. You could say also, x equals 0 satisfies the equation, right? It works. And we can also see that 0, 3 truly is, right? This is truly in our table, okay? And you could actually build your table of values that way, just over and over again. So just to sort of make that clear, let's try it again. So let's clear out some space here. Perfect. Okay, now I'm going to rewrite that equation. Okay, so the number of tiles, which is y, is based on the rate of change multiplied by the position number, and then we'll add on how many tiles are in the 0th position. So let's this time take, well, what would be good to use here? Well, we could use, well, we could just check 2. So we'll take 2 and we'll substitute it in here. We could do that. So let's do that. Okay? So we're going to set x equal to 2, and I'm just going to write this out. You see, when you use parentheses beside any number, it means that we're multiplying, just in case you weren't sure about that. So here's what we're doing, okay? Really what we're saying to the person, and I know the fraction, it could be a little bothersome, but I want to share something with you. So ask yourself this: how many halves do we actually have here? Well, what we have, I'm just going to put this negative out front here, but essentially we're taking 5 and we're multiplying it by half. We're taking 5 1/2 to make this 5 over 2, which is a negative number. That's why the negative is here. So 5 over 2 is 5/2, which is really 5 copies of 1/2. And then we're multiplying that by 2. Now we do have to follow BEDMAS, so please don't forget about that. Multiplication before addition. So focus on this now. The 1/2 and the 2. And ask yourself the question: what is half of 2? Well, I'm hoping we're all, excitedly shouting it's equal to 1. So we have our -5, and half of 2 is 1. So really, when you multiply -5/2 by 2, you end up with -5. And then we'll just add on our 3. So y is -2. So what does that mean? Well, it means that positive 2 for x and -2 for y is a point on the graph. It means that x equals 2 works or satisfies the equation. And it also means that this should be in our table. And if we follow it through, yeah, it is. It's right there.